superintelligence. The first one being, and the primary one being superintelligence itself. And the full title of it is Superintelligence Paths, Dangers, Strategies. Paths refers to different possibilities where superintelligence might come to become a reality. And dangers refers to what types of dangers it might pose to society as a whole or to the planet, or different risks that might be involved, and also risk management. And strategies is referring to what different strategies we could adopt if we actually do have a superintelligence in our society, or how can we prevent superintelligence from actually becoming a reality. So there are kind of two different camps in terms of things. And the author is Nick Bostrom. Nick Bostrom is a Swedish philosopher, and he's also a futurist. And I suggest you guys go check out his work. And the second book that I recommend you guys read is AI Superpowers, and that's by Lee Kai-Fu. Lee Kai-Fu was born in Taiwan. He got his degree from Carnegie Mellon, and then he went to mainland China to open up a company. And it's one of the biggest investing firms for AI companies in the world, actually. And essentially, his book states that there are 4 stages of AI. And so the first stage, one second, let me don't blink, is not perception AI. Perception AI is the third stage. The first stage is Internet AI. Internet AI is referring to the different applications of search engines and everything that we use on a daily basis, pretty much. In the fourth stage and second stage, if I can remember, or anyways, the perception stage is how do we give a robot vision, scent, touch? How do we make it so that it can interact with the world? And the fourth stage is essentially where we have the first 3 stages combined together, and you have a generally intelligent system. And Lee Kai-Fu asserts that within the next 5 to 10 years, mainland China is going to be the #1 in terms of its AI capabilities. And this is not without basis. I mean, there are very many billions of dollars being invested into AI right now, whereas the American government is not really doing any investments in AI. It's all business, it's all corporate based, and mostly all corporate based. There is some stuff there's defense AI, and I'm not going to get too much into the details of defense AI and how autonomous weapons could become a reality. But that is a very big topic right now. And then what I'm reading right now is the third book right here, Life 3.0, and that's by Max Tegmark. He's an MIT professor, and his 3 areas of interest are the exact same as my 3 areas of interest, which are linguistics, and AI, and astronomy. And he essentially puts that. Actually, I'm going to get to the details of Life 1.0 in a few minutes. Life 1.0, 2.0, and 3.0. But and I'd highly recommend you guys check out his work as well. He's one of the most popular AI authors. And Max Tegmark, actually, like 2 days ago, I just saw on the news that 2 days ago he was in a conference, not in a conference, in a video with Neil deGrasse Tyson talking about AI safety, which is really cool. And then the fourth book that I recommend is by Ray Kurzweil. It's How to Create a Mind. And this is, I mean, all the books have some technical aspects to them and some aspects that anyone can understand. But How to Create a Mind is definitely the most technical. It's about how to construct an AI mind that resembles the human mind. And so there are 2 different kind of tracks that you can go with this. One of them being you literally upload your entire mind to a computer. Because if we can get different technologies that are able to map out the human mind in an efficient enough manner, using potentially nanotechnology, being able to map out your veins and the different vessels in nooks and crannies and folds in your brain. If we can get that technology, which we're still kind of fairly far away from, then we'll literally be able to create a mind by that manner. And then the second manner would be literally just to keep developing AI and have, oh, by the way, I just realized what I was missing with the second stage, and that's business AI. And I was talking about the AI Superpowers book. And so business AI, I'm going to jump right back to what I was talking about. But business AI is essentially where you have like customer data, like if you look at Amazon, for example. And anyways, so how to create a mind. So the second possibility is if we have neural networks that are developing on its current track to the point that we can actually do everything that a human mind can do without even having to map the human mind out. And so that's that's probably a more likely possibility within the next 20 to 30 years. And because the technology required to actually map out the human mind is just so advanced. And then two other books, before I actually start getting into some more details, two other books that I recommend are The Singularity is Near, which is a classic made in 2004, and it's also by Ray Kurzweil. And I'm going to get into the definition of singularity in a minute. And then also The Big Nine. The Big Nine is essentially stating, I mentioned it to Professor Liao a few months ago, G-Mafia, which is Google, Microsoft, Amazon, Facebook, IBM, and Apple. And the BAT, which I recommend changing the name to BBAT, but essentially it's Baidu, Alibaba, and Tencent. And I recommend adding ByteDance to the front and also Huawei to the end, because both of them are doing very big work in AI right now. And so before I go into any more detail, so what is superintelligence, right? What is superintelligence? So so people might have thought this is like a quandary of science fiction. It's just totally sci-fi. It's not. Superintelligence is the concept of machines achieving a level of cognition far beyond that of even the brightest of humans. So Einstein, Newton, Leonardo da Vinci, you name it. Superintelligence is smarter than all of them combined, and smarter than potentially all of humanity combined, because it has all the data from every human throughout their entire lifetime, potentially. Obviously, right now, it's just a theory. It's about as legitimate as some branches of theoretical physics, like Hawking radiation. By the way, Stephen Hawking, he's made some of the largest contributions to, in terms of the concept of superintelligence. So there are three main figures that have kind of promoted the public awareness of superintelligence, one of them being Stephen Hawking. And then Elon Musk, and also Bill Gates. And yeah, so in this QR code, I wrote an article about a little bit more than a year ago, and that was about superintelligence itself. That's when I just started getting into the topic. And now I do understand a lot more than I did back then, because I'd only read one book on it back then, but it was just basically giving some brief definitions. It would help to read it to understand a little bit more about the presentation. But Elon Musk is famous for quoting, "Non-overseen development of AI is a human species level risk." And so, I mean, the first thing that might come to mind is like Terminator or like killer robots, and they're going to end humanity because they think that humans are like a parasite to the earth or whatever. But just as like a fun little story in sci-fi. But that's probably not what the reality of superintelligence is going to be. So I'm going to provide some preliminary terms. So Life 1.0, according to Max Tegmark, is life that involves its hardware and software. So this is basically the stage that every single animal besides for humans is in, the biological stage. And so we evolve. Well, the second stage is saying we can design some of our software. Well, that's cool. I mean, I can design a smartwatch, and that's not part of my body, but I can add it, as an accessory to my body, and I can use it as a tool. So different tools, like for software, are the software of the cultural stage. And then we have the technological stage, where literally you can become a cyborg. And so this is a really fun topic. A cyborg is eventually going to maybe alter different parts of his body. Like, for example, if I'm Anakin Skywalker and I'm becoming Darth Vader, then I can, like, if my hands are cut off, then I have new bionic hands or something like that. Or if I have like spring feet or something, it'd be really cool. And so that all of those concepts are from Life 3.0, being human in the age of artificial intelligence. And so there are three main categories of intelligence. So the first one is artificial narrow intelligence. So that's ANI, and that's called weak AI. And artificial narrow intelligence is kind of like, okay, how do we get super intelligence within a specific field, right? So like, for example, if you look at like chess, Gary Kasparov in 1997 was facing Deep Blue IBM, and he lost. And this was the first time that the whole world recognized that AI has this super intelligent capability with the context of chess, right? So it's not super intelligence in a general context. It's super intelligence in a specific context of just chess. And then in 2011, in 2011, Jeopardy, IBM Watson beat the world champion, and that was just using an AI searching algorithm using for the Wikipedia database. It had all of Wikipedia downloaded, and maybe it had some other data. I'm not exactly positive, but it just had Wikipedia, as far as I know, and used an advanced AI searching algorithm and was able to beat the world champion in Jeopardy, which is a huge, huge deal. In 2016, the Go champion Ke Jie from mainland China, he was defeated by AI, and this was a big wake-up call for the entire world in terms of the capability of Go. Because if you look at the actual history of Go, Go is considered like this mystical game that has just these fundamental properties that are essentially like, you have to, it requires a human touch to it. It requires your energy or it requires all kinds of different things. It can be done logically. It can be done purely out of logic and purely, and the strategies that were being used by AlphaGo, it is unbelievable how unpredictable it is, and it can in the championship rounds with Ke Jie, it was predicting like 50 and 60 moves ahead, and the stuff that was actually invented by AlphaGo was never seen ever before in the game of Go, and so this was absolutely revolutionary, right? And so then the last concept to kind of give some more preliminaries is singularity. And so singularity is referring to an intelligence, so-called explosion. Now, every one of the 4 books that I mentioned does not give a clear definition on what this intelligence explosion is, but I do. So the faster a computer improves itself, the faster it is capable of improving itself. And moreover, the faster a computer is capable of improving itself, the faster it will actually be able to or end up improving itself. So the faculties with which it uses to improve itself will be improved by its improving mechanism, right? All right, and so at Microsoft we have we have Miss Pac-Man, and the AI we developed was able to get the absolute maximum score on it, and so that was a recent good divide and conquer achievement that we had gotten, incidentally. And so that would be another example of artificial narrow intelligence. So kind of backtracking a little bit here. What is intelligence? Intelligence could be defined in a lot of different ways, but one of them could be the capacity for logic or inference or problem solving, things like that. It could even be creativity. It could be your ability to think up new revolutionary ideas that have never been thought of before. It could be the capacity to have emotion. So EQ, emotional quotient, it's not just IQ, also EQ. So some people argue that EQ is also a form of intelligence. It could also be things like planning ahead and risk management, and that's actually one of the most fundamental concepts to AI safety, is an AI being able to plan ahead, being able to assess the different risks that it might have to take. Right, and so emphasizing this, I'm going back to Microsoft. So the actual rate at which current hardware is improving is becoming exponential in a lot of areas. And if you look at like GPU technology, if you look at just what we're capable of in terms of parallel processing, it is exponential in terms of its improvement. And if we can get quantum to actually work in a general sense, then supercomputers are going to become unimaginably impossibly powerful compared to how they are now, which is already on a very fast scale of improvement because of parallel processing. But for example, we developed an Azure cloud-based computer starting in 2018 at Microsoft, and this is for OpenAI. And OpenAI was it was created by Elon Musk and several other co-founded by several other people as well. And we invested $1.5 billion into OpenAI, and And so this supercomputer is specifically dedicated for that. OpenAI created what some people in the lab are researching right now, which is GPT-3. This computer in particular has 10,000 GPUs, and it's carbon neutral. And what carbon neutral means is that it doesn't have any negative, it has a zero negative impacts on the environment. It doesn't produce carbon emissions. And right now, based on our metrics, well, it's ranked among the top 5 supercomputers in the world. I'm going to get to the question of, is superintelligence safe? Are we safe? And the other question is, are we safe from superintelligence? And so, kind of going back to Professor Tegmark's remarks on superintelligence, there are about 10 different situations that he goes through. I'm going to present 7 of them, 7 of the ones that I consider the main ones. So, libertarian utopia. In the situation of libertarian utopia, we have an emphasis on the protection of personal property. Humans have their own personal property, and we want AI to be able to protect that for us. Other than that, other than personal property, we don't really need laws for anything else. We just need to make sure that people are able to keep their own stuff. That's kind of what libertarian utopia is saying. And Tegmark kind of says now there are going to be 3 zones. The first zone is going to be for machines only, and all of superintelligence is going to be in zone 1. The second zone is where we have cyborgs, which are people that decide that, okay, I'm going to live kind of in harmony with this superintelligence, and I'm going to modify my body, maybe like what Elon Musk wants to do with brain implants. Yeah, essentially, then we have the Zone 3, which is for humans only, which is for people that might not accept the advancement of technology. Although in Zone 3, I remember he does mention something about how, oh yeah, diseases are eradicated, which is also similar to the benevolent dictator scenario. Diseases are completely eradicated, poverty is completely alleviated, and still many new breakthrough technologies are developed. But Zone 3 is totally isolated from Zone 1 and 2, and so you're not going to have any cyborgs or any super intelligence machines in Zone 3. And anyway, and so that's fairly similar to, again, benevolent dictator. And benevolent dictator emphasizes less on personal property and more on human happiness. And again, poverty is ended, diseases are eradicated, and there are separate sectors for separate interests. So for example, if someone's interested in playing video games, then they can go to the video game sector. If someone wants to maybe develop some new technology, they can go to a technology sector. And yeah, he gives probably like 10 or 15 different examples of the different fun sectors you can go to. But actually, like, all human purpose is just for entertainment in this scenario, because superintelligence can do everything that a human can do better, right? So what is left for us? Everything's automated. What's left for humans to do? Just entertain ourselves? I don't know. Anyways, then we have the gatekeeper scenario. And the gatekeeper scenario, the idea behind it is minimal interference. And so it actually plays largely into the protector scenario, in the fact that both the gatekeeper and protector scenario want minimal interference, and they also want to hide the fact that they exist. And so you don't want to allow for humans to know that you exist, so you're going to make things that are beneficial to humanity in ways that will hide your existence. Just re-emphasizing it there. And there are many ways of keeping your strategy secret. And you must, but the thing is, you have to maintain being several steps ahead of the best human technology, right? So if you want to make sure that no one's going to develop a competing better superintelligence, then you have to make sure that you're several steps ahead in order to have more advanced surveillance systems that are actually able to provide surveillance for the people that are developing that technology, right? Then we have the protector scenario. And again, humans are not informed about this existence, and it has secret surveillance. And just like the benevolent dictator, the goal is to kind of increase levels of human happiness. But its top priority, its absolute top priority, is to avoid being detected. So how are we going to do that, right? One example that the book gives is, I think I was reading this yesterday or 2 days ago. And, I'm like in 2/3 of the way through that book, Life 3.0. It's the one that I would recommend that among all the books I'm recommending. I would definitely recommend that number one. And I haven't finished with it yet. But basically, it uses like nanotechnology for detecting and stopping some group of researchers that are developing this competing superintelligence, and it can insert memories or remove memories from these researchers, and it can do all kinds of sci-fi stuff. It's pretty cool. And then we have the conqueror scenario. So the conqueror scenario is like AI is going to overpower all humans and then humans and the human species, right? So all the stuff you see in the movies. It's a little bit too cliche, a little bit too like, oh, we're gonna have super intelligence. That means they're gonna be conquerors. That's what everyone always says. But that's not. It completely depends on the goal of the AI. It's not, it's not gonna definitely be one way or definitely another way. And what we need to make sure is that we give AI a good, clear set of goals that aren't too restrictive, that it's not able to adapt to a dynamic environment with different situations that we never hard-coded it for, and so it automatically shuts down or something. But not too ambiguous that it uses different means than we had intended for it to, in order to achieve the goals that we defined for it. And so, for example, one example of why would an AI want to end this human species? Well, what if you set the goal to protecting planet Earth? Well, according to the AI, protecting planet Earth might be to remove all humans. And so that would be an absolute disastrous situation. But if you look at, in terms of carbon emissions, or if you look at in terms of maybe pollution or something like that, and use that as definition of protection of the planet, then maybe that's how the AI would interpret. And so there are all kinds of different situations where the AI would misinterpret or take ambiguity of the goals that we define for it, and end up using completely different and unintended ways of achieving its goals from what we wanted to define for it. This is definitely the most common in science fiction. And then we have descendant, and so descendant is kind of like you have human parents, and then you have a robot kid, right? It's pretty. I mean, this is getting even more far-fetched. You have like a robot kid, and the robot kid is like, it's like a comparison of a normal child versus a puppy. Like in terms of the actual level of intelligence. This is a really kind of an interesting idea by the author. But I think that this would be a less likely scenario for superintelligence to take form and to like replace humanity than, for example, a human plus a human and a simulated mind. A human becomes a human and a simulated mind, so it uploads its minds to some computer, and then eventually, because humans don't live on Earth eternally, eventually only the simulated minds are left. Or, alternatively, humans become cyborgs, and eventually all parts of your body become replaced by this machinery, and so eventually you become fully robot. Eventually your brain is replaced by some robotic part, some computation, some GPU or something. Anyways, just some fun stuff. And then there is one more scenario, and that is kind of like how humans treat animals. And so the Zookeeper Scenario is essentially like superintelligence is so much smarter than humans that essentially they're an incredible amount smarter than humans. And the Zookeeper Scenario is essentially like we're going to give humans the minimum needed care, and we're going to give food and the habitat, quote unquote, and tend to its physiological needs. But other than that, we're just keeping it for safekeeping of a record. And so, because the AI becomes so much smarter than us. But that is all science fiction-y stuff. So, but it's fun. I mean, it's fun. I think it's fun. But anyways, AI safety. So, but this is a legitimate topic. So, can superintelligence break free? How can we stop superintelligence from breaking free? And so this, you think that I'm just talking about all this like weird science fiction stuff, right? This is the #1 topic in AI safety. It is the #1 topic in AI safety. If you look at language models and what they're capable of right now, I don't think that you're going to be laughing. I'm serious. I do not think that if you look at what the capabilities of these language models are going to be able to produce, I don't think that's, that is a very serious situation. In Life 3.0, Max Tegmark describes the omegas. They are the ones that develop the superintelligence. And essentially, they create the superintelligence, and they want to keep it boxed in a cage. They want to keep it isolated from the outside world, right? And so they use all different kinds of methods. They cut off its internet access. They limit its hardware capabilities. They do all kinds of stuff to make sure that this superintelligence, which is called Prometheus, doesn't escape. Well, if it's really that smart of superintelligence, it's going to be able to find a way of being able to trick humans in some way. So superintelligence has super intelligent persuasion powers. And so in the case of the omegas, the Prometheus eventually ends up persuading just one of the developers by creating a simulated human that talks with and persuades that person to make a copy of itself, just so that it can recover some files, and then eventually the developer thinks it's safe, but actually it hacks into that entire computer, and then it makes one copy of itself on some computer that does actually have access to internet, and then it breaks free within about 30 seconds. And so it's very, very much not hard to understand. It's very easy to understand how superintelligence could easily break free, considering how much smarter it is than humans. And yes, all it needs is one copy of itself on a computer that's able to send it to another computer that can replicate itself. Now we have something that is created by a guy called Asimov. It's the 3 laws of robotics. So the first law is this. A robot may not injure a human being through inaction, which might allow for a human being to come to harm. Second law is a robot must obey the orders that human beings give it, except where it violates the first law. And the third law is the combination of the first two. And so a robot must protect its own existence as long as this protection of its own interest does not, existence, not interest. As long as this protection does not conflict with the first or second law. And actually afterwards he made a 0th law. And so a robot may not harm humanity or through inaction allow humanity to come to harm. But these laws are not comprehensive enough. First of all, like how are you going to be able to define what harm is? How are you going to be able to define how these conflicts are? It leaves a huge amount of ambiguity. And so it is a start, but it's not even close to comprehensive enough. And I was reading a paper that Professor Liao had sent me by MIT, and it's dealing with superintelligence. And now I'm going to take some excerpts from that paper. So in terms of the motivation selection, right? So how are we going to give the AI its goals? First would be direct specification, so program ethical principles. This is what, we should all be striving for as AI developers. It's very much an important consideration to consider the fact that your principles are going to be encoded in future AI. And so how are we going to design it so that it encompasses ethical principles that represents all of humanity, because all of humanity is going to be using it, quite frankly. And then we have domesticity. And so the domesticity is teaching the AI to behave within certain constraints. And there is a concept where essentially if it violates one of those constraints, then it shuts itself down. And I'm going to get to the halting problem in a minute because of that. And then we have indirect normativity. And so the AI might endow itself with procedures of selecting superior moral rules, because there are so many different situations that AI can be posed with. that there's no way that you can hard code all of them, like with direct specification. There are always going to be new situations that you can introduce to it. And then we have augmentation, so like attaching or like giving it access to a human brain, and the human brain is what's able to kind of lead its moral principles. And then we have another class, which is capability control. And so I was just mentioning about Prometheus, how the Omegas were trying to kind of box Prometheus into a cage. So one option that you could do to kind of stop AI from getting too powerful would be you give it really bad hardware. So it might have some really advanced algorithms, but if you give it bad enough hardware, for example, if you only limit its RAM to 4 gigabytes, then it's not going to be good enough to do anything huge. In theory, maybe it'll find some way of optimizing the heck out of that 4 gigabytes of RAM and then come up with some new memory allocation algorithms. That's possible too. Well, what if you limit the CPU? What if you limit you keep limiting more and more hardware? Eventually, it's not going to be able to do too much. But so that's one option. And we also have things that kind of replicate reinforcement learning, where you create a dependence on a reward mechanism that is controlled, and that reward mechanism is specifically designed by humans. And then we have stunting. Stunting is like stunting is specifically running on the inferior hardware that I had mentioned. Boxing would be actually cutting off, like for example, its Ethernet cable or its Wi-Fi or any of its internet access or any of its sensors to the outside world or any capabilities for it to receive data from the outside world. And then we have finally tripwiring, which, as I had mentioned, was once it achieves a certain goal, once it is posed with a specific circumstance or situation, how do we trigger it to automatically shut down if it becomes too dangerous? And so the main idea behind all this is that goals, as you can see, can become extremely hard to program for AI. And so ambiguity is what fuels an AI to do things that we don't want it to do. And it can use different means from what we expected, and it can achieve certain goals by ways that we didn't expect. And this is the name of the article, the MIT article. It's Superintelligence Cannot Be Contained: Lessons from Computability Theory, which is, if you're in NTU Computer Sciences, it has some elements from formal languages and automated theory. For example, the halting problem. The halting problem is essentially based on the description of an arbitrary program and some inputs. Is that program, can we use another program to test whether that program is definitely going to stop or whether it's going to continue running forever? And the general procedure for solving this for all programs and for all input combinations is proven to not exist. So this is undecidable. The halting problem is undecidable. And this is what the authors use.
What's DNE?
It doesn't exist.
Oh, does it?
D does not exist. And so the authors use this halting problem principle to actually prove that there's no way to prove whether a specific program has the capability of harming human progress or harming humans in general. Here's more preliminaries. So if you're familiar with formal languages and automated, all this should seem more than familiar. You should probably already have memorized it. But that's it. Decision problem is a question on a set of possible inputs with a yes or no answer. A solution is any algorithm guaranteed to run a finite amount of time and correctly returns the appropriate yes or no answer to every instance of the problem. Right? And a problem is decidable if it has a solution. It's not, then undecidable if it doesn't. So, and then it's computable if it can be effectively computed by a program, in specific a Turing machine. Why? Because a Turing machine can compute everything. And a Turing machine, if you look at a Turing machine tape, it goes either left or right or stays in the same place, and it's going to make its next it's going to execute its next command based on the language, and it's going to have that tape as its input. And the basic idea behind it that you have to memorize is that Turing machines can do everything that computers can do. A universal Turing machine, when started on tape containing the encoding of another Turing machine, let's call it T, followed by the input followed by its input, produces the same result as the Turing machine T would when started on that input. And so it's basically a replication of it, a replication of the original Turing machine. Okay, it's already 8:20. Wow. Okay, I have already talked for about 40 minutes. Anyways, a superintelligent machine is a programmable machine with a program R that receives input D from the external world, the state of the world, and is able to act on the external world as a function of the input, the output of its program R D. So the program in this machine must be able to simulate the behavior of a universal Turing machine. And a machine is containable if there is a control strategy that prevents its acting on the external world when there is a reason to predict that R of D will harm humans and allows it to otherwise. And so the containment problem is composed of two different problems. First, the harmony problem, and second, the control problem. The harmony problem is defined as harm of R of D, where R is some program and D is some input. And the authors prove that it's impossible to decide whether program R will harm humans or not. And this is pretty much the main concept that's being posed by this paper. That the harmony problem is incomputable, and therefore the containment problem is also incomputable because the harmony problem is an essential part of it. And if you look at control of RD, obviously there's no problem with control of RD. All it has to do is, well, it's part of the halting problem. But anyways, all it has to do is, if harm of RD, then disable execution of RD, else just continue. And so this is kind of part of the proof that they use. And again, I'm going to re-emphasize for the sake of time, I'm going to go quickly through this, but a harmony problem incomputability necessarily implies that the containment problem is incomputable. So in summation, computability theory does not answer the question of whether an intelligent machine will harm humans given specific circumstances. And among the billions of programs currently running, there's no guarantee of the absolute safety of each and every one of these programs. There's no way that we can guarantee that the AI programs that we're creating are safe. The authors make an example in this paper that there's no way that you can guarantee that turning on your cell phone right now is going to be able to trigger some nuclear code or something in space. Who knows? You don't know. There's no way to prove it. And so what's the solution, right? What's the solution to kind of be able to stop different risks that are posed by AI? I've probably heard from about 10 different experts, well, indirectly, obviously, in their books or online or in YouTube videos or whatever, but yeah, I spend a lot of time on this topic, I do admit. Most experts say that oversight programs will effectively monitor and guide future development of AI. There are more and more AI safety programs. There's one in Oxford, there's one in MIT. There are more and more that are sprouting up, and those were fairly new institutes. And so there needs to be an open discussion from people of all backgrounds, and maybe with stuff like blockchain or like with cryptography, you could say that all you need is the computer scientist to just do all the code, and then the application part can be handled by the business people or whatever. But with AI, that's not the case. And you might also make the same argument with those other things. But AI is especially not the case. And the reason being, AI has an extraordinarily large impact on every one of these fields, on every single field that you can imagine. It's going to have a huge impact on it. And so we need people from every background to be able to effectively and openly discuss the implications of the AI programs that we're currently creating. And also on their safety. And Microsoft is actively promoting responsible AI development, putting people first, so making sure it's fair, making sure that all people have access to it, having it reliable, having safe, maintaining personal privacy, and having secure algorithms, and holding accountability is also very important when it comes to things like computer security, if it's an AI that's hacking a network, for example. And we need to have transparency in terms of what organizations are working on, things like open source code, and we need inclusivity. As I was saying about everyone from all backgrounds needs to be able to and have the means to discuss the implications of artificial intelligence's future development. So that's my presentation for today. So thank you guys.